Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, salam kebajikan, salam sejahtera, dan selamat siang kami ucapkan kepada hadirin sekalian. Selamat datang dalam acara The Future of Energy in Indonesia. Pada kesempatan kali ini, Urban Energy Session didukung oleh APUEA, Asia Pacific Urban Energy Association Informa Markets. Dan pada siang hari ini kita memiliki dua panel diskusi. Kami mengucapkan selamat siang dan selamat datang kepada yang kami hormati, distinguished guests, ladies and gentlemen. We would like to allow Mr. Peter Lundberg as Executive Director Asia Pacific Urban Energy Association, Bapak Suroso Isnandar selaku Direktur Manajemen Risiko PT PLN Persero, Bapak Rana Yusuf Nasir selaku Wakil Ketua Dewan Pakar Masyarakat Konservasi dan Efisiensi Energi Indonesia, Ms. Hui Kiwon, Manager Business Development Keppel Energy as a Service, Mr. Adrian Lim Hock Heng, Chief Operation Officer Projects KJTS Group, Mr. Chiam, Global Customer Support Hub Manager for IEC LV Motors Division at ABB, Mr. Osmond Manurung, Head of Sales Renewables Energy Power and Water PT Yokogawa Indonesia Yokogawa, Mr. Binu George, Business Development Director BCIS Indonesia, Mr. Kinyu, Regional Application Engineering Leader Cargill Bioindustrial, Mr. Hogan Liao, EP Transformer Expert DuPont Nomex Energy Solutions. Dan seluruh tamu undangan, asosiasi dan partner, teman-teman media, serta peserta pameran yang kami banggakan. Perkenalkan, saya Firly yang akan memandu acara pada siang hari ini. Izinkan untuk melakukan sesi ini dalam bahasa Inggris. To all invited guests of the association partners and media, as well as the exhibition participant who we are proud of, let me introduce myself. Firly, allowed to conduct this session in English. Ladies and gentlemen, Energy Talk Series 20 is part of Pamerindo Sustainable Events, which is our sustainability mission to embed sustainability into all activities that we do and encourage industry stakeholders in it to do the same, which covers all sides of operations, business practices, to provide understanding and information to our community network so as to build a positive impact. Without further ado, we invite Mr. Peter Lundberg to give introduction session. Mr. Peter, the stage is yours.
Hello everyone, my name is Peter Lundberg. I'm the Executive Director of the Asia Pacific Urban Energy Association. So we are the organizer of this event together with Pamerindo Indonesia. So I want to thank Pamerindo Indonesia for working with us to create this event. So we are here to talk about future of energy in Indonesia. And what we mean by that is basically we want to present a number of solutions and technologies that exist today to help Indonesia in its energy transition, right? So we have quite a lot of speakers here today, so I will try to be brief, but I have some slides I just want to show some as an introduction to the session. So my presentation is ready, or? Can I have my presentations? Number one. Well, I can just, while we're waiting, so we are an industry association based in Bangkok, Thailand, but we are operating in the Asia Pacific region. We want to promote sustainable urban energy or solutions and technology that really can help, the region to reach stated climate targets, reduce emissions, to create a better society for us all. So this is just one event of many that we do. So next week we'll actually go to Vietnam to have a similar session. But normally we do around 10 events per year, bringing together solution providers, politicians, policymakers, investors, and so forth, to really to move the energy transition forward. Okay, so this is a few of my slides. So we call it the future of energy, as what we are building today. When we are talking about energy, the energy system that we're building today, these are the energy systems that we are going to use in 2050 or 2060, when we have set net zero targets, right? So what we do today is very important. So if you look at this graph, this is actually from IEA, just kind of comparing different measures, how to, let's say, in a rough way, how we can reach a net zero world, how to say, or to reduce emissions. So, and there's a lot of talk about renewable energy, right? But actually, the most important measure that is shown in this graph is efficiency. So energy efficiency is actually more important than renewable energy in the energy transition. So we have to keep that in mind. But of course, renewable energy is more attractive. So, but I think it has to. We need it all. We need all these solutions, right? So, but energy efficiency is very important, and we have several speakers to address this today. I just also want to show. So this graph shows basically a comparison between available renewable energy resource. Is the graph more than 3,600 gigawatts? And by the way, this is data from IRENA, International Renewable Energy Agency. But the incurred installed capacity in Indonesia, I mean, in the power sector, is about 81 gigawatts. So you can see here, only the available renewable energy resource is huge. So you only need you to use 2% of the renewable energy resource to cover the capacity that is already installed. But this is okay. This is capacity. It's not energy. So it's just to give you some thoughts, right? And you can also see here the installed renewable energy is only 13 gigawatts. So it has really room for improvement. But I'm sure Mr. Sorosa from PLN will address this in his speech. So this just shows you of the available renewable energy resource in Indonesia. The biggest available resource is solar, but that's the fact in basically all countries. So solar is the biggest, followed by offshore wind, and then you have hydro, geothermal, and biomass as well. All right, so I don't want to speak any longer because we have so many great speakers waiting for their turn. So I just want to show you the program here. So we have basically, you can say, 3 different sessions. We have a keynote address from Mr. Sorosa from the PLN, followed by 2 panels of discussion. The first one is going to be on district cooling and its potential in Indonesia. And then we have a future energy technology outlook, right? So stick around. We have a very great session. Thank you very much, and back to you.
Okay, thank you, Mr. Peter. And next, we invite Mr. Suroso Isnandar, Director of Risk Management, PT PLN Persero, and Executive Chairman of PGCI, to deliver the keynote speech. Mr. Suroso Isnandar, the stage is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. It's really a pleasure to be here with all of you today. The distinguished speaker, also the Honorable Peter Lundberg, the Executive Director, and also Pak Rana Yusuf Nasir, Indonesia Energy Conservation and Energy Society, and also Pak Edi Widiono from PJCI, and all the delegates who appear today. My name is Suroso. At the moment, I'm taking care of risk management in PLN, and one of the biggest risks that we are looking at the moment is the climate change. The Earth is warming, Everybody knows that we are regularly facing an irregular weather pattern. Whatever CO2 emission happen here in Jakarta will have the same effect in other places in the world. Any emission in New York, and the impact will be felt here. So the global emission is really common agenda of every population in this world. And as we can see that the data here is taken from the NASA temperature data. The temperature is getting increased, and this increase will have a very, very severe impact. Everybody will be experiencing those, and therefore we are, as one of the contributors to the carbon emission, we have same responsibility or even bigger responsibility in taking care of this environment. As we can also see in that, next slide please. Before we start looking at how we approach the solution, we need to have a look what we have at the moment. In Indonesia, our current fuel mix is still dominated by fossil fuel, where almost 65% of our energy mix is come from coal. And this is not a surprise for us because coal is one of the cheapest energy sources in Indonesia. So it's very logical to have those. However, we have to change this approach. We have to move away from the thermal base, and we have to go into the renewable energy in the very near future. As Peter mentioned on the presentation, that the potential of renewable energy is huge in Indonesia, I think more than 3,600 gigawatt, and the utilization of those is very small. So therefore, we have a vision in the future that we must do the transition toward a more sustainable and balanced energy mix in the future. Ladies and gentlemen, in COP, which is every year has been conducted out from COP 26, 27, 28, PLN is pledged to committed to reducing greenhouse emission. And therefore, we launched the program of net zero emission by 2060. At the moment, our emission level reaching 310 million ton CO2 per year. If we do nothing, then by 2060, it will more than 1 billion ton CO2 every year. Definitely, they will have a very severe impact. And therefore, PLN has pledged a program called Net Zero Emission by 2060, and we implement those through the program called Accelerated Renewable Energy Development, or we call it ARED, which is committed to changing the course of the energy landscape into the cleaner energy sources. Next. Sometimes it is very easy to develop and to find the solution on paper, but when taking into action, then this is a bit challenging. So the question is, how are we going to work with the program in the talk? So PLN is not just setting the ambitious goal, we are actively taking steps in realizing them. And this initiative is part of our greenest power development plan, which is now running from 2021 to 2030, which emphasizes the decarbonization of the fossil-based power plant and also the aggressive development of renewable energy sources. And this is what we are doing. First of all, we cancel a 13.3 gigawatt new coal power plant, which is planned to be online in 2019, 2028. And this will avoid at least 1.8 billion ton CO2 emission. And secondly, we also cancel the power purchase agreement, something that we signed with the developer of coal new power plant, the one which has been signed but not being developed or constructed. And this will reduce 0.2 billion ton of CO2. And that's not enough. We're also replacing 1.1 gigawatt of coal with renewable energy sources, and this will further reducing our emission by 0.2 billion ton of CO2. Is it enough? No, this is not still enough. Then we are replacing 800 megawatt coal existing power plant with the cleaner gas power plant. And this cutting down another 100 million ton of CO2 during the lifetime. And not only that, the step 5, we are committed to utilize the existing coal power plant by adding biomass, hence reducing the coal emission. And we have a plan of using biomass at our 46 coal-fired power plant. And probably by 2025, we are reaching 52 plants, which will use co-firing up to 10%. And this is contributing to a reduction of 0.1 billion ton CO2. And this is still not enough. We have a scattered power system which is smaller in size. As we know all, the Indonesia consists of 17,000 islands, of which only 5,000 inhabited. And to reach those population at the moment, we are using the diesel power plant. So we're launching a program called the dieselization program. It's basically converting those diesel power plant, which is 1 gigawatt or around 1,000 megawatt. Just to put things into perspective, 1 gigawatt equal 1,000 megawatt is more or less able to electrify 1 million houses. We will remove those and change with renewable energy, and it will reduce another 0.1 billion ton from our emission. That's still not enough. PLN then taking another step. That's we are also implementing carbon trading. So I think in the area, this is the first carbon trading exchange, similar like Jakarta Stock Exchange, of our 55 coal-fired power plant, targeting we can trading the carbon up to 5.26 million tons. And finally, and this is the last or pulled step, that we are planning and developing at least 21 gigawatt of renewable energy plant under current new power development plan or RUPTL, which is running from 2024 to 2033, which will save an additional 1.2 billion ton of CO2. So if these initiatives are successful, then it's going to be projected to result in a total cumulative emission reduction or avoidance of 3.7 billion ton CO2. So if one car emits 5 kilograms CO2 emission per year, so what we do is equivalent of removing million of cars from the road permanently. And this is the bold step by PLN. However, this is not easy step. We understand those. With this new landscape, then our future will be look like this, that 75% of electricity of PLN will come from the renewable energy. We are going to accelerate it, the coal-fired phase down, using the accelerated renewable energy, and then 25% of those will be served using gas, and that's still not enough because we have to make sure the stability of the system. That means we will need a base loader, and that will open a room for the new type of energy, which is a nuclear energy. So in this graphic showing 2024-2040, we will have a new additional capacity of 82 gigawatt, consists of wind and solar, 28 gigawatt, and then the baseload renewable energy, which is hydro, geothermal, is around 31 gigawatt, and the gas power plant, 20 gigawatt, and therefore there will be some space for the nuclear power plant. And hopefully by implementing this commitment into the action, we will achieve net zero emission by 2060. And that not only a dream, but a reality that we can achieve. Ladies and gentlemen, next slide, please. Unfortunately, there is a mismatch between the location of load center, which is here in Jakarta, for example, in Java Island, and the sources of renewable energy. And the circle here showing, the red circle is showing where the center of load is situated. And the bigger the circle, the higher the load. and the, the blue circle showing the renewable energy sources. So there's a mismatch between the center of the load and the center of renewable energy sources. The center of renewable energy resources mostly in Sumatra Island, which is next to Java Island, and also in Kalimantan Island. Meanwhile, in Java Island, there are some potential, quite big, but still less than what we needed. So in order to harvest, in order to changing the landscape and also addressing this mismatch, we are developing what we call the green supergrid. This innovative infrastructure project is basically designed to connect the renewable energy sources across Indonesia to the demand centers. And then by building this green supergrid, we will ensure that the energy from the remote areas is efficiently transmitted to where it is needed, creating a more balanced and better shape of energy system. The green supergrid will include strategic transmission inter-island link using high voltage DC, HVDC, Sumatra and Java interconnection by 2029, and also the Sumba, Bali, Java by 2040, and also Kalimantan and Java link by 2035. And this new transmission line, new backbone of renewable energy is very critical. It is a fundamental means for us in order to transport and facilitate the implementation of renewable energy. And by this, we can transport the renewable energy from hydro, geothermal, solar, wind, from the various locations into the center of the load. Next. Building the long and also complex transmission will need special approach. We will need special technology, what we call it smart grid, and also flexible generation. And therefore, the smart grid is one area where PLN will focus on, and by this program, hopefully we can manage the long super green grid with these various renewable energy. And with the new landscape of renewable energy, the nature of the electricity business will change. With the conventional power system, the variability only situated on the demand side, meaning that it is the behavior of customer who dictate the generation of the power plant. But the variability of the renewable energy sources will make the variability come from two sides, the supply side and also the demand side. And therefore, we will need accurate weather prediction, better network diagnostic, smart dispatch system, or even smart defense schemes. Basically, a smart grid which has become a must-have thing for Indonesia in order to move its landscape from the fossil base into the renewable energy. Next. And the implementing smart grid will basically boosting up the installation approximately 28 gigawatt of wind and also solar by 2040. And in contrast, if we are not building any smart grid, then only 5 gigawatt of variable renewable energy can be installed. And that will be very far away from of what we needed. So as we can see here, using the smart grid implementation, then the 28 gigawatt of the new renewable energy can be implemented efficiently and still maintaining the stability of the grid. And this ambitious project, ladies and gentlemen, will end up in one thing. Next slide, please. As we look at the future, that it is clear that the challenge will become from any side, not only the source of energy itself. Finding the new sources of renewable energy is one thing, but transmitting and building the new network is also very essential. And therefore, PLN cannot do it by ourselves. We'll need collaboration from every parties. We will need strong commitment from every parties, and we are open this opportunity to anybody interested in fulfilling in our huge variable renewable energy projects. Therefore, I agree to come to this very excellent conference in order to have a better knowledge, good networking with you all, and basically this program cannot be executed without participation and collaboration from all stakeholders in this sector. With that, I will end it my presentation, and thank you very much for your attention. Thank you.
Thank you very much, Mr. Soroso. A very comprehensive introduction to the energy transition in Indonesia. So I just have a few questions quickly I want to ask you. So in your opinion there, so maybe, yeah, you can have a seat if you want.
Yes.
What is the biggest challenge, in Indonesia right now to achieve these ambitious targets?
Okay, actually the very basic challenge is one thing, the mindset of all the stakeholders. I don't disagree in this forum, but I definitely sure that everybody actually agree that the climate warming is happening. But to a certain degree, there are still some mindset that thinking that's not the case. So the first challenge is make sure that everybody are talking on the same page here, having the same mindset. And this is not only in fulfilling people by people, but also on those stakeholders, the regulator, the regulation maker, and also the industry itself, that we need to change, that we need to move away from the fossil fuel, and we have to go into the renewable energy. That's the first challenge. The second challenge is by changing this landscape, we are fighting two fronts. The first front is we are looking at the new type of sources and also the technology involved. On the other things, Indonesia is developing country and we have to maintain building a new infrastructure in a quick pace. And this will put a very, very heavy financial pressure into the PLN. So the second challenge is the financial side. Therefore, we are open for collaboration, and government has been trying to relax the regulation on this area in order PLN can achieve this net zero emission program. So I think that's what I thought regarding the challenge.
Great, great. And just a quick follow-up. So changing the mindset, what should we do? It's a hard task, and we all have to help each other to do. Is there something that you can recommend us to do?
It is very understandable. For example, if I look at myself, for example, if I have to sacrifice my comfort way of living, sleeping with the aircon on, for example, we just reduce that actually by 2 centigrade Celsius. That will make a huge impact on the energy conservation. As a fun fact, if we have a very hot weather in this island, in Java Island, then the electricity load will increase by 1,000 megawatt. So there is a huge difference between the hot day and the normal day like this. And this comes to the energy efficiency. So changing the mindset, it's going to be a continual effort and also concerted effort through the education, through the campaign, through the forum like this. So that's why we have the Association of Indonesian Society for Conservation Energy. It's very good, Pak. That's really one of the media when we can communicate to public that changing the mindset, starting with energy conservation is really the way to go. And this can be doing with many ways. For example, our means of transport. I'm quite glad now because we are seeing more and more electric vehicle on the road, and PLN also contributing by, we are at the moment already providing 1,400 charging station, and more will come. And we also open those into the public. And obviously, for example, changing the way we approach our mode of transport, that can be one way. So basically, it has to be concerted effort for every sector, everybody, with the government, on the stakeholder, and also in the companies, all companies, and also we need to teach it on the schools that changing mindset is really necessary in order to preserve our environment.
Thank you very much. So this is a lesson for us all. We have to help each other. But I think I will thank you, Mr. Soroso, for your keynote, and we move on to the next panel discussion. But thank you, and stay around.
So thank you again, Peter, for this opportunity. I would like to emphasize that PLN and electric sector in Indonesia is changing, and the changing is very progressive and radical. And I sometimes see PLN will change. We are not only taking care of electricity, but our main job now is taking care of environment. Meanwhile, on the same time, we're providing electricity to the people. Thank you for that.
Thank you very much. Back to you, moderator.
Okay, thank you, Mr. Suroso, for your address, and please remain on stage. Okay. Next, the memento presentation and photo session. We also invite a representative from Sales Director PT Pamerindo Indonesia, Ibu Wiwi Roberto, to join us on stage to present mementos to the speakers. Okay, we kindly ask for Mr. Peter Lundberg to remain on stage to lead today's seminar session. Each speaker will present for 50 minutes, followed by a 30 minutes Q&A session and wrap up to Mr. Rana Yusuf Nasir, Ms. Hui Kiwan, and Mr. Adrian Lim Hock Keng. We invite you to come on stage. Ya, Bapak Rana Yusuf Nasir selaku Wakil Ketua Dewan Pakar Masyarakat Konservasi dan Efisiensi Energi Indonesia, Ms. Hui Kiwon, Manager Business Development, Keppel Energy as a Service, Mr. Adrian Lim Hock Heng, Chief Operation Officer, KGTS Group.
All right. Yeah. So our next session here, we're going to talk about district cooling, and we have three excellent speakers and panelists here today. So we will start with some presentations, and then we move on to a Q&A, and to really see how district cooling can really help Indonesia reduce its energy consumption and also help reach its climate targets. So I would like to introduce our first speaker, Mr. Rana Yusuf Nasir, from the Indonesian, from Maskei or Ashray, I think, both, right? Yeah. So, yeah. So Rana, please, you can go ahead with your presentation. And yeah, yeah.
Okay. Tolong Pak di ini show belum tampak di screen. Wow. I think maybe the distance it's too far. But I have already checked. I test this morning.
No, they are putting it up.
Okay.
Yeah, we have the presentation, so just bear with us a few minutes. Okay,
Ah, okay. Yeah. Okay, thank you very much, Peter. Okay. Distinguished ladies and gentlemen, my honor Pak Suroso, maaf Pak Suroso, Pak Edi dari PLN dan dari Mas Kay, Peter Lundberg, and all the speakers. So, good afternoon. May I introduce you? My name is Rana. I'm from Indonesia Energy Conservation and Efficiency Society, MASKEI, and also from ASHRAE Indonesia chapter as the Board of Governance. Peter asked me to present the district cooling development in Indonesia, especially in the new capital of Nusantara. Okay. So first of all, I would like to share about the benefit of the district cooling system. To know about the benefit, let's see this slide about that. Okay. For instance, as a case study, we have 5 buildings, A, B, C, D, 5 buildings. And the district cooling means that the A, B, C, D was served or was supplied, the chilled water, by one central system. So 5 buildings become one system, and this is what we call about the district cooling system. So for the case, we take about the 5 buildings, and all buildings served by one chiller plant. And then what is the benefit? Let me see about this table, this matrix about this. Let's say we have the building A, B, C, D, and then we do the simulation for having the cooling load on hourly basis, 9 a.m., 12, and so on. And then if we see that every building already have the hourly cooling load, and then the yellow color means that for building A, the peak load for building A is a 900, is on the yellow cell. 900 is the peak load, and then on the B is 1,200, and so on. So if we see this, then it means that we provide with the individual chiller system. Then for A, we need a 900 ton as the peak load for the building A. And then also so on until the building E, we need about 1,800 ton. So the total capacity of the building, the total capacity of the cooling load of the chillers of these 5 buildings is about 6,300. That is a summation of the peak load for every building. For the district cooling, of course, because this is centralized, then we can sum for each hour on hourly basis. For instance, on the 9 a.m., we have a 4,495 ton, and so on. So every hour we do the calculation, and then if we look at the bottom line, we can see that the maximum on the cooling load is about 5,250. So what does it mean? If we provide with the district cooling, instead of that we provide with a 6,300 ton ref, as a total capacity chiller, if it is individual, then we is enough to provide with 5,250 as the instantaneous peak load. So what does it mean? It means that we have already reduced the cooling load for about 16.7%. And what is the benefit of this? Because 5,250 ton, then we can use a bigger chillers, for instance this, okay? So for every building, if we look at this, then we need about 450 ton each. Then if we use the district cooling, 5,250, maybe we can use about 500 ton instead of 400. And it is a smaller numbers of the chillers that we use. So the bigger capacity of the chillers, this is the graphic about the efficiency of the chiller, kW per ton. The bigger the capacity, the lower the kW per ton, or much more efficient. So this is one of the benefits. The other is about the pricing. I just mentioned the pricing, but it's not the total absolute pricing, but it's on US dollars per ton. The bigger the capacity, the lower on US dollars per ton. So this is also give you a lower investment, and that is one of the benefit. So conclusion is the bigger cooling capacity, the better, give more benefit. District cooling system with a big capacity will be better, 1 DCS for the area, for the whole area. So benefit of district cooling, I just go through less number of equipment, less number of moving parts, of course, jadi less maintenance, lower on investment costs, less in energy consumption, lower and blah, 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 blah. That is a lot of the benefit. The global implementation of DCS is just only for our reference about the global DCS implementation, like on Macau, on the Studio City, there is a 1 DCS serves for a lot of the building, and the capacity of this district cooling is 90,000 ton ref, very big. For instance, let's see this complex, the Jakarta Fair, because I was the one who installed the chiller unit. It was 30 years ago. I know the capacity is for this big complex. We only supply with 3,000 ton. You compare with the 90,000, it is big one, okay? And the other is in Sweden, your country, Peter, okay? It is the total capacity of this area, the capacity is 94,000 ton ref. And the piping, the length of the chilled water piping is almost 250 kilometers. Very big. So then, how about the district cooling system in Indonesia? 2 years ago, we as Shri have an event here about the district cooling, where the Director General of the Public Works Ministry Office also attend as a keynote speakers. And after the event, she called me to her office, and then we discussed about the district cooling. And then because she is responsible for the development of the new capital, he said that, okay, I make a decision that we will implement the district cooling system in the new capital. Of course, that's a good sign for us, Peter, at that time, okay? So, of course, my mind was, at the time, that the district cooling system will cover the cooling for the whole new capital. For the whole new capital, I said, like this. Ideal concept as the DCS covers all area of the new capital with 1 district cooling. But the DCS in new capital, the ideal concept is 1 central DCS. But what we do is that the final concept, the DCS is implemented per clusters. I will explain about the clusters later on in the following slide. So there are many or several DCS systems for the whole region of the new capital. For instance, this is just only a part of the new capital, and the color, the block color means a building or the complex there. So there's a DCS, district cooling, for every complex, for every cluster here. And for instance, the number one is the complex for the President Palace. The capacity only 2,400. You can compare with the 90,000 ton that we mentioned before. So this is the biggest DCS in new capital, 2,400 ton ref. And as all the others are very, very small. So what does it mean? I can call that this is not a district cooling system. Sorry to everybody, including the Ibu Director General, about that. This is not a district cooling, but I call it a cluster cooling system. Not the DCS, but the CCS. You know that after the character D come the character before the D is C. So before the district cooling, we come with a cluster cooling system. Okay. So 1 central district cooling become to the clustering of the CCS, some of them. For instance, this is a 1 complex about the coordination ministry office. There is a 4 ministry office, number 1, number 2, number 3, number 4. For every minister, coordination minister, there's a one cluster contains about 4 until 5 building, you can see there. So every ministry or coordination ministry office of a 5 building, for instance, there's a 1 district cooling system. So for instance, this is have a 4 on this complex. So what does it mean? Why goes to clustering? It may be because the budget availability and scheduling about the schedule, the agenda of the project construction and the development make it not on one time. So that is maybe the problem. And because of the hilly terrain, the area there for the new capital is not a flat ground, but that is a hilly one, okay? So I know that that will be a problem when you install the chilled water piping instead of a straight piping. It should be ups and down, up and down. Maybe there is also a problem. So the clustering that we did there, it will lose the opportunity to get a bigger benefit, of course. So what is the challenge in Indonesia? Of course, we have a potential for the DCS in Indonesia, especially on the developing urban area like Serpong, Pantai Indah Kapuk, di Cikarang, whatever there. So what we have to do is working together with the big and well-established developers. In the area, of course, we can focus that on the 2 areas, Jakarta and Surabaya. What is the barrier and challenge for development? This is the last 2, Peter. I'm sorry about this. Lack of awareness of and expertise, solution conducting awareness campaign, workshop, and everything like we have today. Regulatory and policy challenge clear regulatory frameworks and policies about the land use, the implementation and operation of this system. Solution developing the clear regulatory frameworks of politics include setting standards and everything there. I think I will share about what happened in Dubai. Maybe you can share about that. You are more knows about that. What I heard that in Dubai, the government there is for one area, there's a regulation, you cannot have your own chiller plant. You have to use the central chiller plant so that will establish what we call about the district cooling system. So this will boost the district cooling concept to be implemented in Dubai. So that is what we have to do, the intervention from the government. The others is about a high initial capital investment, of course, on the first place, and the market perception and uncertainty demand. Uncertainty demand makes all the developers maybe still on the big question whether I will go to the district cooling or just step by step, one cluster to the other, one building to the other building. The challenge, the last slide, Peter, sorry. First is currently the district cooling has started being introduced to Indonesia market by implementing in the new capital. Yes, we know that it is a cluster, not a district, but this is, I think we can say, this is a good start. This is a starting point for Indonesia. The other is that the demand to district cooling will increase significantly after this. I do believe, I have a confidence for that. And I think this is the right way to go by introducing the district cooling, right, Andrea? And the other says about the government approved to implement district cooling in the all-government complex in the new capital. This is a good sign. And what does it mean? That currently the level of knowledge of professional for district cooling shall be improved by organizing the capacity building, especially in cooling load simulation, control system, hydronic chilled water piping design, and etc., etc., etc. So we have to hold a capacity building, Peter. Maybe we have to start about how to public awareness, socialization about the district cooling. And the last but not least is the government intervention. This is a must to do. Government intervention by regulation to push industry and market for DCS implementation. I think that is the end of my presentation. Thank you very much.
Thank you very much, Rana, for a very good introduction to the district cooling in Indonesia. I think you highlighted some very important points. maybe we can come back to a little bit after the other two presentations, right? Thank you very much, Rana. So next, I will move on to Ms. Hui-Chi Woon from Keppel, who will talk about a little bit from a Singaporean perspective as maybe one of the leader of district cooling in the Southeast Asia region. So,
hello.
welcome, and the floor is yours.
Okay. First and foremost, thank you everyone for coming today to listen about district cooling. I rarely meet so many people who like to think about district cooling, meeting at one spot and talking about it. And thank you, Peter, for organizing this. Let me start off with my presentation. Okay, yeah, so today I will speak more about applying district cooling through cooling as a service in brown and greenfield projects in Singapore, no, in Indonesia, sorry, yeah. Okay. They can't. Next slide. Okay, so before I continue, let me introduce you on the agenda today. So I will give you a short introduction of my company. I'm from Keppel District Heating and Cooling Systems. We do own heating and cooling systems around the world. And let me share also on what is cooling in the district concept and what is service, buying chilled water as a service. What is the concept and why do we do it around the world? And finally, how can I apply this in Indonesia? Many developments in Indonesia are already sort of brownfield. Can we still apply district cooling or cooling as a service concept? And what about greenfield projects? So I'm also very happy to share with you a picture of my plant. This is our first plant in Singapore. It's built in 1998, and as you can see, it's still looking very well, and it's still one of the best in terms of efficiency around Singapore. So this is Green Mark Platinum level. In Singapore, there's a green certificate rating given to buildings and to buildings using district cooling. So all my customers in this district park do get the highest accolation from the government. And 2 years ago, we refurbished the office, and we are proud to share that we are Singapore's first positive energy building. So we put in a lot of solar, and we actually have a positive energy building in Singapore. I'm from Keppel. We do fund management, investment, and operation of large-scale assets. I'm from the operating arm. I focus on infrastructure, and I do have sister company dealing with real estate and connectivity. So connectivity is about data centers, telcos. We do have businesses in Indonesia. Oh, and this is my positive energy building. So it's a 11-year-old office. We retrofit, we put a lot of solar, vertical solar, rooftop solar, and green wall. And if you are in Singapore one day, you can contact me. I will bring you around my building. So this building, we control all our assets around the world, especially in Singapore. It's a one-stop shop where I control all my district cooling plant or standalone chilled water plant, EV charging, solar installation, all within this building. And it's not new also. This concept has been around 20 years. We just made the visual being different. The control has been there for the last 20 over years. Oh, yeah, so as I mentioned, we do have operations across 20 countries. And I'm from the infrastructure arm. We have two main verticals. One is on power business, whereby we are the first in Singapore also to build a combined cycle gas turbine power plant that runs on hydrogen. So all our customers that buy electricity from us are buying green electricity. And this hydrogen comes from India, Australia. We have several contracts around the world. And we also have a brown energy power plant. We are one of the largest we have one of the largest market share in Singapore. And lastly, we have renewable import. We are also the first to build this ASEAN power grid, whereby we green electrons from Cambodia, Laos, all the way to Singapore since 2022. And recently, this year, we are also awarded by our government a conditional approval to bring in solar from Indonesia to Singapore. So Indonesia is really one of our closest brother in terms of energy transition. I'm from the sustainability arm. We have waste and water treatment. Around the world, we are easily top 3, top 4 in terms of doing waste and water. We serve the government directly. We sign contracts with government. And I'm from the energy as a service arm, whereby I go around, sell energy to building owners, governments, or to real estate owners. Okay, so what is interesting about Keppel is that we serve all forms of energy. Usually in Singapore or in Indonesia, if a company is an energy company, that company only specializes in one form of energy or two forms. But in Keppel, we specialize in all forms of energy that a single building owner might need. A building owner will need aircon, so he needs cooling. He needs solar, he needs EV charging, and we do provide them within a single company. So what we are very proud to say is that we have 50 years of engineering track records, and I think this is very credible to all of our customers. And this is one of the reasons why we can tap on our experience and go around ASEAN and the world to sell our services. Okay. So this is a summary on how can we value add to our customers. So today, our customer has a certain baseline emission. He has a lot to cut down. How can that customer reach net zero? Such as how can Indonesia as a country reach net zero in 2060? So we come in first, we give you solar. Solar is impossible to use solar to decarbonize the whole building consumption, maybe 10%. If you have a very large flat roof, maybe 20%, but what about the remaining? So as our keynote speaker has said, a hot day will generate an extra 1,000 megawatt of energy consumption. And if we can save 30%, it's very, very significant on a daily basis, and this could be done through district cooling or me coming in to do cluster cooling as well, or standalone building cooling services. And we have other solutions through renewable energy certificate or green electricity to help you reach your final net zero target. Yeah. So to introduce more about my company, we were set up by JTC. It stands for Jurong Town Corporation under the Ministry of Trade and Industry. So back then, the Singapore government want to invite a lot of investors to come set up your manufacturing plant, your data centers, your regional HQ. So our government is very wise to have a master planner. We have many business parks in Singapore, and if every business park has a centralized cooling, what's the impact? So you can imagine if every house in Indonesia has their own power plant, it's very not economical and not sustainable. So similarly, every building owner don't need to have their own chiller plant. They can have a shared chiller plant and have 30% savings or more. So along the years, we gained more projects around the world. And in 2009, we got bought over by Keppel because JTC want to focus on its master developer core business. So it's a master developer developing business part. This cooling business is being outsourced. So recently we won a tender in Bangkok called by the government, whereby we clear up a piece of land. As you are familiar, Bangkok, there are many makeshift settlements. There are a lot of markets. We cleared them. It's being built into a new campus, office, retail area, and there's a centralized district cooling that serves that whole cluster. And we also won the Jurong Lake District and many new projects in Singapore recently. Yeah, so this is a summary of some of our key portfolio around Singapore, Bangkok, Tianjin. Tianjin, we use geothermal for their heating purposes in winter time. So this is one key feature of a centralized heating plant as well. Yeah, so we have quite a number of properties in Singapore using us, semiconductor, data centers, and so on. And I would say this is not, district cooling is not limited to only office building. It can be used for multiple users. And the key definition of district cooling is that it must serve multiple use. So in the daytime, I serve commercial building. At night, I still have chillers. I serve residential buildings, or maybe data centers because they run 24/7. So this centralized plan, from an investor point of view, your payback comes faster because it's used throughout the time, and it's better than each of the building having their one plant to serve only 8 hours or 10 hours. It's very inefficient. Yeah. So here are some of our customers. And I think Mr. Nuna has explained very well what is the chilled water system, what is a district cooling system. Here are some pictures of a small little plant that I took over in industrial estate. So that place is very far from our nearest district cooling zone. So what can we do to this building? And this guy has some chillers on board already. How can he work with me? So we help them to retrofit one chiller. You can see, and there's still a spare plane, so he can install a new chiller when his load goes up. And overall, we can achieve 20-30% energy savings. And I think the interesting thing is that Keppel being a big chilled water provider, I call tenders for equipment replacement. I can call on a larger scale, so my capex is cheaper, and I operate 80 over buildings in Singapore using a centralized team, so I can share my O&M costs. And hence, our customer can see upfront savings and also recurring savings, and we are always cheaper compared to them running on their own. And on the district cooling concept, we have also explained earlier, everybody don't need have a power plant at your own building. We can share a centralized plant. And I think maybe I can touch more about thermal storage tank, since Mr. Nuna's part haven't covered. So thermal storage tank is, you can imagine it being just a big tank storing chilled water. It's like a battery storing energy. In the night time in Singapore, electricity tariff could be just 1/3 the price. It's very cheap to buy electricity at night. So I charge my chiller at night, and I will fill up my tank with cold water. And in the daytime, when all my business parks are running, I discharge my tank. And then I can save a lot of money in terms of electricity. Yeah, and my chillers, I don't need to install so many already because I already have the tank to help me offset the capacity. So I reduce my cost, my upfront capex, and recurring cost is cheaper. I don't need to install so many chillers, and a tank has no moving parts. So we have installed tanks in different kind of setting. It could be a steel tank in Woodlands, whereby land is not as premium, but in more sophisticated or recent business parks, all our tanks are in concrete tanks. So within the building structure, I have a concrete tank. You can't see it, but it's behind the walls or in the pictures I've shown. Instead of water, I can also use phase change materials. So we have R&D with the National University of Singapore, whereby that same volume of material, a phase change material is a wax. It can store 3 to 5 times more energy compared to water. In Singapore, space is very, very expensive. So I try to store as many energy as possible. And later on, I can show some applications behind. Yeah, so we have also covered the advantages of district cooling. And here are some pictures that I can show you. I think many of you might be familiar with Micron. Micron is a big semicon company in Singapore. So on the top left hand is Woodlands wafer fab. In Woodlands, their manufacturing capacity has maxed out. You see their plants behind. They have no space to install chillers. So about near 20 years ago, they approached us to do a district cooling. So we are actually building capacity for that, and we are looking at renewal already. We have a very long-term contract and relationship with all our customers. Same for Biopolis, we built for R&D, clean rooms and labs, 20 over buildings in the whole cluster, and that plant was maxed out. We won their second tender, the phase 2 for Mediapolis, which is below. They serve the same area. As you can see, there's a big oval shape. That's our national broadcaster, MediaCorp. So instead of having cooling towers or chillers on their rooftop, they can do their radio, they can put their equipment on the roof. Many industrial customers like us, because they can use their roof to do many other things for their industrial facilities and so on. And MediaCorp is very special. They need two, and it's as if a data center, they need very stringent chilled water supply. So we are able to serve them through 2 interconnected district cooling plants and 2 sets of heat exchanger and pipes for them. So if one plant is down, the other plant can serve them. So that's the beauty of district cooling. And finally, there's Tianjin Eco City for heating and cooling. And some of my customers, as shown in this picture, they have very fantastic roof. They have very beautiful aesthetics. With district cooling, you can do that. If you have standalone plant, you need your cooling tower to be exposed to the air, and you can't do all these fancy things. You have Sandcrawler, where you make your Star Wars movie. It was made here. We have GSK, we have Biopolis, and recently we have Wilma HQ that was opened 2 years ago. And ongoing, we have many beautiful buildings in our portfolio. Yeah, so I can sell chill water to you whether you are on a district zone or you're in a cluster zone or a standalone zone. We share the same expertise, and this is the cost structure for our customers. In Singapore, land, you don't own land forever. For district parks, JTC only gives you for 30 years. So your contract has to be pegged to your land lease. 30 plus 30 years, your extension could be 30 years. So our contract to them is pegged to the lease, 30 years. And for standalone buildings, chillers usually will be decommed within 15 years. Then we'll look at a new set of chillers. So the contract is corresponding to that, about 15 years. We have utility structure whereby you buy chill water as a utility. You pay as you use, but we give customer an option. If you have a lot of money, you want to co-pay with me, okay, you can give me some installation charge. I think this is important more for the government side, whereby you need the government to enable, to make the infrastructure ready for developers to come in. So many times governments want to pay this installation charge in Singapore. And demand charge is like, is to pay for fixed recurring costs, whether you own your chiller plant or not, you still need to pay for your contracted capacity, your O&M. So that's to account for that. And lastly, energy charge, pay for your electricity and water. So it's very clear on what money I'm collecting for you is to pay what. And finally, I want to show how can we convince our customers through comparing your costs. You share with me your investment costs, or I can call quotes, and if you were to invest on your own, what is your cost? Your electricity, water, O&M costs compared to my proposed tariff. We will convince customer based on our proposal and show them that there are at least 20 or 30% savings. Usually each building, when we change their chiller system, is 20 or 30%, depending on how you run your plant. Yeah, this is the short video of our latest win, Jurong Lake District, the second central district of Singapore. Yeah. So there's a central pneumatic waste system and district cooling master plan by the government. We won that open tender. There are different players that try to bid for the tender from France and all over the world. They try to bid this tender, and we show our competitiveness in terms of pricing and our track records. And that is why we won the second CBD of Singapore. So by 2 years' time, phase 1 might be completed, but we are by 2030, we are waiting for the master developer to come in to build the buildings. Yeah, so this is the district cooling system, whereby our pipes will run through a common service tunnel. Some districts, we lay our pipes in the roads. Most of the time it's underground. We rarely run any pipes on surface because land in Singapore is too premium. Yeah, so that's about the end of the video. And I want to end off with applying it in a greenfield project first before I end off with the brownfield. So as I mentioned, the master developer or the authority is very important to master plan and help to co-fund to enable developers to come to Singapore. And hence we are considering them on this. And as for the technical portion about the DCS, it will be system design, commercial terms, and execution. But the most important thing is the mindset of the government, as our keynote speaker has also mentioned. Mindset is the most important. And if we have a shared vision, things are possible. So this is also an example of how I can run a thermal storage tank in the greenfield. If there's space, I can size a 10,000 RTH tank. So this is a sample at our Biopolis. You can see our man is very, very small. there. So in this kind of setting, land is it's very difficult to get such a big piece of land to have such a big thermal storage tank. But if we can get that land, we'll do it underground, and we will charge the tank at night, and then release the chill water in the day. So instead of having, for example, 4,000 RT chiller, I only need less than 2,000. I have the capacity that I need. That's a lot of savings. And 2 years ago, my boss tell me to sell your chilled water beyond our Changi Business Park usual zone. So I have Changi Soft. You look at the Google map, what can you do about it? They are all industrial buildings. They have their chiller system or their VRV system. Can you still meet them, join your district cooling? So 2 years ago, we made an announcement. We put it on the national news that we have managed to connect Changi North and South. Yeah, we won some customers there, and let me share how we connect them. So first case, it has been done in Singapore, so it's the easiest way. Maybe you just connect the 4 plants together. Not much value, but you might save on the O&M because you share a single team. But you might have to consider the remaining lifespan of the plant and the lease of each building, because Singapore's building is only 30 years. So if that building is going to decom or be demolished, what about the other buildings? So there's a problem there when we sign contracts. Then the second one, it is more doable, whereby we take out all the plants in those buildings, and then we connect them to the DCS. So that's what we did in Changi South. And if there's space, we can set up a new plant. And lastly, if all of the above is not possible, no space, no lease, I will have to take over and do on an operator mode. And finally, I have a hangar in Singapore, aircraft hangar. So in the day, the load is very high because there's sun, there's people, there's load. But at night, they just need to cool the aircraft hangar. The aircraft is not moving. The load required is very, very small. Running any chiller would trip the chiller. And buying a small chiller at night to run just for the night load is very expensive. So we built a phase change material tank for them. And then the tank charges before the load is needed, and then it discharges at night so that the aircraft can get its aircon for cooling. So that's the end of my presentation. I hope it's beneficial and you can learn something from it.
Thank you very much, Hoxi. Big applause for that. Interesting to hear about Singapore, and we'll get back to you with some questions a bit later. So next I want to move to our next panelist speaker, Mr. Adrian Lim Ho Keng from Malaysia, from KGTS, so who's going to give insights from Malaysia. And I think Malaysia is the biggest market in terms of number of district cooling projects in Southeast Asia. So the floor is yours, Adrian.
All right.
Just waiting for your presentation here.
Yeah.
So, but as I believe there are, how many district cooling projects are there in? Okay, you can go ahead.
Yeah,
you can go ahead,
okay,
please.
the slides are here. Okay, so good afternoon, everyone. I'm Adrian. Greetings from Malaysia. So, so in line with our topic today, exploring what we could do for the energy sector in Indonesia with Malaysian solutions. All right, so this is me when I'm much younger and slimmer. This is not important, so you'll skip to the next one. So basically, KGTS Group, a very quick introduction is that we have been in business for the past 40 years. We were established in 1984. We started off as an AC contractor, and we have since do a lot more today. So what happened was we were actually acquired by one of the largest energy management company in the world from France, and they basically taught us how to build and design very efficient district cooling plants. All right. So today we are in operation in of course HQs in Malaysia. We have offices in Singapore and Thailand as well, and we are hoping to come into Indonesia next. So in terms of headcount, we have about more than 1,200 people scattered across these three countries, and our solutions are actually applicable across most industries. All right, so in terms of accreditation, we have all the necessary ISO certificates. We are registered with, we are an ESCO company, so whereby we are actually qualified to do an energy audit and come up with energy proposals for our clients. Okay, so everyone talks about sustainability, everyone talks about ESG. So what we try to do since 2017 is to back up what we say with data. So we basically collected data from all of our sites and actually measured how much energy that we save, how much CO2 we avoided. So to date, we have actually saved up to about 51,000 megawatt hours of electricity. That translates to about 32,000 tons of CO2, which is equivalent to about 1.5 million trees. And we are continuing to do so. So despite being in business for the past 40 years, we have only started collecting data about 7-8 years ago. Okay? So in terms of what we do as a company, we are heavily involved in energy management. We are an energy efficiency company. We do full facility management, hard and soft services, static and mobile FM. We also do commercial cleaning services. But today, we are going to focus on energy management, especially on district cooling. So why district cooling? In any typical building or development, the highest consumer of energy is cooling energy. It could be more than 50%, in some cases 60%, 70%. So if we really want to make an impact, a positive impact, this will be the first target to hit. Okay, so actually I got this from the APUA, but this is probably 1 year old, one year ago, Peter. So as you can see, in this region, as what Peter mentioned earlier, Malaysia has the highest number of district cooling plants in operation. It states here 33, but I believe there's about 37 or 38. And I think even Singapore, there's going to be a lot more after this. All right? So why so many plants in Malaysia itself? Like I said, we had a good head start. Back in 1997, KGTS built the first district cooling plant in Malaysia for government sector. And since then, they have replicated it in the commercial industry, in the education industry, hospitality sectors, health sectors. That is why we have so many. And today, we are very proud to say that KJ is directly involved in more than 60% of all the district cooling plants in Malaysia, be it in the design and construction of those plants, operation maintenance, or both. All right, so where is DCS applicable? Basically, you need to have a development that has very high and constant cooling demand. So examples such as mixed developments, you can have a shopping mall, hospital, airports, data centers. Residential is a bit of a tough cookie to crack, but we are trying to get there. So, but it's ideal if residential, what we say, if it's part of a mixed development. That means in the daytime, maybe you supply to offices, shopping mall, and nighttime, the plant is supplying to those residential developments. Okay, so these are some of our clients. You may not know most of them, but they're basically made up of the biggest developers in Malaysia. Players from the educational sector, universities, airports, shopping malls, data centers, semiconductor center, manufacturers, so on and so forth. And these are our clients from Singapore and Thailand. Basically, it's the same. All right, so why DCS? The advantage I have being the last speaker is that I think both Pak Rana and Hui Chi has covered most of them. But just to reiterate, we have to recognize that cooling in this region today is no longer a luxury, it's a necessity. All right? Hospitals need cooling, data centers need cooling, even shopping malls need cooling. If you were to operate a shopping mall without aircon, there's going to be, a very tough sell to your customers to hit to your mall, right? So, so instead of trying to think outside the box, I think we are trying very hard to actually make the supply of cooling energy as efficient as possible. So as what Peter said just now, energy efficiency might not be as sexy as RE, but I think it's the way to go. Okay, so very basic economics on what actually is needed to supply cooling energy. Basically, you need a capex for the DC cooling system. All right, there's the cost for operation maintenance to operate and maintain the plant, and of course your utility charges, which is the electricity and water. So all the costs put in together is basically how much you need to supply 1 unit of cooling. Right, and as mentioned earlier on, in most of, if not all developments, cooling energy would demand more than 50%, in some cases 60 to 70% of your cost. So let's make a difference here by making it more efficient. So challenges. What is preventing us from implementing DCS? Pak Rana has covered most of them earlier, thank you. All right, so, but I think the key takeaway is to have all the stakeholders, as also mentioned by Pak Suroso earlier on, is to get everyone on the same page. All right, be it the policymakers, the consultants, the developers, the master planners, the contractors, the consultants. If everyone is on the same page, it's going to help accelerate our effort to have a very energy efficient and sustainable cooling system in place. All right, so what is the solution to all this? Very similar to what Keppel is offering, basically to offer providing cooling energy as a service. So very similar to a utility provider, be it power or water, we supply cooling energy at a fixed cost, at a fixed tariff. So the owners or the end users don't worry, they don't bother what goes on at the back of house. All they're concerned about is, I pay for how much I use. That's it. And as a service provider, what we guarantee is supply, uninterrupted supply of cooling energy at a fixed tariff. Right, so what we do the design, we do the construction of the plant, we operate and maintain. At the end of the contract, we transfer all the assets back to the client or the end user. And if need be, we can also invest up to 100% of the capex to mitigate all these risks from the owner. It gives the owner or the end users all the comfort they need, that there's no risk. All the risk is mitigated for them. Right? And it's going to be borne by the service provider, because this is our bread and butter. We deem ourselves as specialists. This is what we do day in, day out. So that way, we feel that this model is a game changer. It works for us in Malaysia, in Singapore, and Thailand. We are very confident it's going to be applicable in Indonesia as well. So, as mentioned, it's applicable in greenfield and brownfield projects. Greenfield, basically, we design, we guarantee the efficiency. So 20 years down the road, we're going to tell the client that the same design efficiency that's applicable today will be applicable in 20 years' time as well. So that way, there's no excuses of wear and tear. There's no, there's a human error, for instance, that causes the client to suffer losses. All this is being mitigated through this model. With brownfield, it's more interesting. How we do it is we take one step before that. We do a very detailed energy audit. So we're going to set a benchmark. Together with the client, we determine where you stand today in terms of your efficiency. And then after the audit, we crunch the data, we crunch the numbers, we're going to come up with a viable proposal and tell you this is how much we can save you. And this is guaranteed on paper throughout the duration of the contract. So upon the completion of the retrofit, you get the benefit of the immediate savings, just like in the greenfield. So this has been replicated for the past 40 years, I would say. But where we are today, we have implemented advanced tech, such as IoT. Why IoT? IoT is basically we're going to plug in a lot of sensors into the system, and with these sensors, we get data. With this data, we can measure. When we can measure, then we can see how to improve. Otherwise, we're shooting blanks. Right? So this is real data that we get day in, day out. So this, regardless if it's in Singapore, in Thailand, in Malaysia, all the data gets fed back into our command center. We have a team 24/7 crunching, analyzing, and today, together with AI, we can do things a lot faster. So we can see how it's self-modeling, it's self-improving. So for example, if I got 10 district cooling plants under my umbrella now, what works for one should work for the other 9. So if something works for plant A, we're going to implement it throughout all the other plants as well. That way, everyone benefits from the savings. Okay, so again, just to go into more detail, AI helps eliminate human errors. It reduces the dependence on manpower. Because, for example, you have a very good operator today, a very good technician today sitting there. Tomorrow he resigns, he leaves the company. You have to hire someone else and retrain again. With AI, we can eliminate that risk. All right, and data is real time. Every minute, or in certain instance, every 30 seconds, we get new data coming in. So that way, AI, together with the expertise of our team, we will then analyze this data together. And of course, it's accessible anywhere. As long as you've got internet access, if let's say you're taking a holiday in London, through your mobile phone, through your tablet, with internet access, you can see real time how efficient your plant are. If there's an alarm, what the alarm is all about, which equipment are running, which chiller is down, which AHU is choked, you get it all at your fingertips. So this is the benefit of this system that we have in place. And it gives you the comfort, it gives our client the comfort that we don't just rely on the team at site, we also have another team 24/7 where all the engineers, the designers, the constructors are sitting there just looking at all this data. All right? So, what's next for KJ? Yes, we are talking about phase change material, PCM. Keppel has got a head start. I've asked them for the secret formula. They said no, so I have to do it myself. So we are developing together with nanotech companies as well as universities to do this. So I hope the next time I see you guys, I have something more to share about this. And we are also embarking on waste to energy. In Malaysia, I believe from the data that we gathered, there have been no success stories in terms of waste to energy in Malaysia. So we are hoping that we could be the first one. And with this if it's successful enough, then we hope to actually roll out more of such opportunities for the rest of the country and also in Indonesia and Thailand, Singapore. And lastly, we want to bring our solution to Indonesia. We have studied the landscape. It is very similar to where we have been operating now for the past 40 years. So we believe whatever the success stories that we have there can very well be replicated here as well. Key takeaways, I think Pak Rana and Huishi has covered most of them. So basically, it's a win-win to all. All right, maybe there's something that we didn't touch upon is we are actually, by implementing DCS, it's actually a very sustainable, efficient system in providing cooling energy. So apart from cost saving, apart from being efficient, right, you're also doing the environment a huge favor, having a very big impact. Because like I said, in this region, aircon, cooling energy is a necessity. All right, so a very quick case study before I end my presentation. So this is our client. They have 14 chiller plants scattered all across the development. So 14 out of the 14, 12 of them are highly inefficient. What we did was we did a detailed audit, energy audit, and we're going to centralize all 14 plants into one. All right? Yeah. So I believe this is being done in Bali Airport, right? Yeah, in Bali Airport. So it was 3. Yeah, so 3 become 1. In our case, 14 into 1. And I think very similar to what Pak Rana mentioned earlier on, this is a very hilly area. Highest point to lowest point, the height difference is about 220 meters. All right, so we're going to decommission most of the plant, put in the heat exchangers, and again, same thing for the client. We guarantee the efficiency, we guarantee the availability. All right, so we're going to be here for the next 10 years. This is a 10-year contract with the client, and the capex is invested by KGTS. Right, so again, guaranteed savings for the client. Operation maintenance is also included part of the package. Everything is linked back to command center, and for the client, 0 capex, 0 risk. All right, that's about it for me. Thank you.
Thank you very much, Adrian, for also very good examples from Malaysia. Good to see the progress there. We are running short on time, so I would just keep us a short and sweet Q&A, and then maybe you can catch the speakers when they leave the stage. Yeah, I'm sure they're available. Yeah. Maybe just follow up with you, Adrian, there. So how much savings do you promise in a case study or like an example of the case study you show? How much energy can you save?
Okay, in this case, for this particular project, we guarantee a savings of 33%. So basically, most of the plants are within a range of 25 to 15 years old. And I said, the more inefficient it is, the better our proposal will look. All right, but there is one standalone building that we finished the retrofit recently. All right, it's in the north of Malaysia, and what was surprising is 2 months after we finished our whole exercise, again with performance guarantee, we got a message from the client and said that they are being audited by the power or the utility provider because after the retrofit, 2 months after that, their consumption dropped by 55%. Electricity bill dropped by 55%, so it triggered the utility provider to go and audit the site. So to us, this is a very, very strong testament that our solution actually works.
Great, thank you, Adrian. So, Huishi, are there any specific lessons learned from Singapore when you talk about implementing district cooling in Indonesia? What can we learn from Keppel, from Singapore?
I think Mr. Suroso spoke about the mindset. After speaking to many Indonesia counterparts, the mindset of owning a chiller plant is very important to Indonesians still. This is the same in Singapore 10, 20 years ago. Do you really need to own your asset to be efficient, to save money? I think that mindset has to be overcome first, and then we can roll out on a large basis. And Singapore government has tried and tested in the last 30 years. I think we are on a good track to also apply or educate or help our Indonesia counterparts to install district cooling system. Yeah,
Great.
That's the main thing.
Great, very good answer. I agree with that totally. And the last question, Mr. Rana. So what do you think is, what can we do in Indonesia to push the development for district cooling?
Thank you. That's quite a good but
it's
a
a big
difficult
question.
Good but a difficult question. Yeah, that's right. No, for coming, I think, from the Bangkok, I already saying that we open the door for any cooperation or join together at that time. We invite all from the overseas to have a cooperation on developing the district cooling in Indonesia. Because cooling is one of the very important utilities that we do need for that in Indonesia, especially that Indonesia is a hot and hot climate.
And very popular, with a
And
large
very-
population.
Yeah, that's right. So one thing for me, that's a two, I already mentioned in my slide that the first thing is that we have to improve the capacity, the potentials of the scientific knowledge that we do have from any professional that in Indonesia. So we needed something like a capacity building, Peter. And of course, as we opened our doors to have something like that, in terms of like we hold seminars like this, or maybe a training course, a short training course, I think it's quite good. That's one thing. The number two is about the intervention of the government. Because we study from the Dubai, that intervention, the government role is very important on developing the district cooling, and that is what we do need here. So that's why we are lucky that in new capital, that the government has already an intention and also put the program or the project for the implementing the district cooling in the new capital. Even it is as a starting point, starting step, not as a one DCS, but many of a cluster cooling system. So I think that's the way. But there's another thing that you mentioned about the centralized of many chillers to be one centralized as the district cooling that you do in Malaysia. 14 of the chiller plant you centralize to be one, like I already have done in Bali International Airport. 3 chiller plant centralized, and what is the saving from there? It is about 21%. But with the retrofit replacing the chillers, the inefficient chillers with the new one, which is more efficient, we got about a saving about 33% at that time. So that's the way. I think we agree on so many ways that we can do. There is many of opportunity that we can work together. So let's work together for that, right? Thank you.
Great answer. And I think that will conclude our session. So a big hands to our panelists today. And please catch them when they leave the stage if you want to ask them questions. So I think there will be some photo session, right? Yeah.
Okay, we would like to thank the speakers who have given great knowledge to all of us. And please be available to stay on stage. And next, we invite you to come up to the stage for the memento presentation and photo session. We also invite a representative from Country Manager PT Pamerindo Indonesia, Ibu Lia Indriasari, to join us on stage to present mementos to the speakers. Oh, Bapak Anton. Bapak Anton, Executive Coordinator of PGCI. Okay, we kindly ask for Mr. Peter Lundberg to remain on stage to lead today's seminar session, Future Energy Technology Outlook. Each speaker will present for 50 minutes, followed by a 30 minutes Q&A session and wrap up. Therefore, to Mr. Chiam, Global Customer Support Hub Manager for IEC LV Motors Division at ABB. And then Mr. Osman Manurung, Head of Sales Renewable Energy Power and Water, PT Yokogawa Indonesia, Yokogawa. Mr. Binu George, Business Development Director, Business Indonesia. Mr. Kin Yu, Regional Application Engineering Leader, Cargill Bioindustrial. And Mr. Hogan Liao, AP Transformer Expert, DuPont Nomex Energy Solutions.
Hello? Yeah. Okay, gentlemen, have a seat, please. Thank you very much. Very welcome to the next session. In this session, we will also continue talking about some technologies that is available here right now to help Indonesia in its energy transition. So similar to the previous session, we're going to start with some short presentations, followed by some discussion. So I will just start with the first speaker, Mr. Siam Chiesung from ABB. So please, the floor is yours. So can we get the presentation for ABB?
Testing. Right, so a very good afternoon, everyone. Selamat siang. Right, today I'm very happy to be here. Thanks invitations from Peters, right, to share about the sustainability target with industrial energy efficiency. So let me introduce myself here. My name is Chiam. So working in ABB for 14 years. So currently leading a team of 4 members to provide the technical support in our supporting regions in Asia. So, yeah. So the next questions we will start. Everyone is talking about the energy efficiency. So do you know why it is so important? Yeah. So let me, I think just now the speakers has mentioned, right? So, but I will still give you some infographics here. So has anyone thought about how many degrees separates the ice age compared to today's climax? Yeah? So when you see photos, back in 1.8 million years ago, during the ice age, the temperature is about -3 degrees Celsius, right? And later on, in 1835 to 1850s, where the industrial revolution is coming in, so the temperature will come, raise up to 0 degrees Celsius. And the climate change starts from these periods. And you can see after 1850s here, the temperature keep increasing. And until last year's, the temperature measure is about 1.54 degrees Celsius, right? So comparing to the ice age time, so the differences is about 5 degrees Celsius. So 5 degrees Celsius, it sounds like very minor changes. But in fact, yeah, it affects a lot, right? The iceberg start to melt, so it makes what? The sea levels increase. So you can see most of the areas in the world, some places is disappeared. Let's take one example in Italy, Venice. There's no car on the streets, right? People are walking on the water, right? So it's because the sea levels is increasing. And the next example, let's talk about Jakarta. Why you are moving your capital to Kalimantan? The reason is because the same. The sea levels is increasing. So in case here, we are not doing anything, what will happen in next 75 years? The curve will go linearly up, right? There will be another 4 degrees Celsius increase if we are not doing anything right now. Okay, so as I mentioned just now, uh, in the previous years here, 5 degrees Celsius has made our species disappeared, land disappeared. So what if another 75 years, another 4 degrees Celsius increase? Yeah, and that's why IEA, International Environmental Agency, has came out these scenarios in order to reduce the carbon dioxide emissions and achieve the net zero. So what does it mean by net zeros? So net zero means here, we would like to reduce the carbon dioxide emission to a level where all the carbon dioxide, the balanced carbon dioxide can be handled by our environment naturally. Yeah? So by looking at this here, so just now, Peter, from the beginning, you have shared this curve already. We have CCUS, carbon captures and storage, fuel switch, renewables. Yeah, I think renewables is very popular right now. Everyone is installing solars, including myself. I've installed solar panels for my homes. Yeah. So, but if you see here, the most effective way to reduce carbon dioxide is high efficiency. Yeah, it's very easy. You just bring out the old equipment and replace it with the high efficiency equipment or the goods. It will help to reduce the carbon dioxide significantly. Yeah, and back in 2016, yeah, we have these Paris agreements, right? Paris agreements, we have 195 countries join in, and they commit to join in this energy efficiency movement together in order to reduce the carbon dioxide. And that's why nowadays you can see a lot of topics talking about carbon reductions, sustainability, ESG, and so on, right? So, I'm actually coming from ABB Motion business here. So it's covering the models and also the drive products. So what is happening right now in the world? So you can see from the screen here, growing energy demands. If you see the electricity consumption globally, the so-called consumption is increasing linearly, and we foreseen by 2050, the consumption will increase up to 40 kilowatt hour in trillion, right? So this is because the population is increasing, right? So when your population increase, what you need to do, you will build up a lot of houses, high-rise buildings, industries, and so on. And you will consume a lot of electricities, right? And then it will lead to climate change, right? So just now you see the curve already here. So the temperature is keep on increasing. And the next challenges we have is resources scarcity, limited resources. So it makes what? The resources cost, the commodity price keep on increasing, and that makes your goods price also increase, all right? So what is the effects of electrical motion? So why electric motors playing a very important role is because electric motors here consume 45% of electricity from the grid. Yeah, so it's almost half, right? If you look in these buildings here, do you see any motors running? Very simple. You look at the back, the lift. Why the lift can go up and down? Because a motor is running hiddenly up there, right? If you go to the toilet, you wash your hand. Why the pressure is high? Because there's a pump running. Escalators, why can go up and down? Because there's a motor hidden inside the floor. Yeah? So actually, motors is everywhere, but you can't see it, right? And that's why motors play an important role in order to reduce the carbon emissions. Yeah? And by looking at the statistics, yeah, only 10%, it's almost like 90% of the motor in the world right now is running direct online, right? So, which means you switch on the switch, motor will start to run. But very sadly, 20% of this energy were dissipated as losses. You pay for the electricities, but you don't get anything in terms of values, right? So, how can we improve it? Yeah, we can actually bundle it together with frequency converters, we can actually adjust the speed of the models according to the actual application needs. Okay, let's say you're staying in a room with the air conditioner on, and you're feeling cold. Usually what you will do, you'll take the remote and you adjust the speed, you adjust the temperature. Actually, that is the function of frequency converter. But in the frequency converter will adjust automatically. Yeah? So let's say like pump, right? The pressure is too high. So in traditional way, what they do is they use mechanical valve, right? They use the valve to reduce the flow. But is the motor still running full speed? Yes. The motor is still consuming 100% electricity, right? So it's a waste. So by applying the frequency converters, it can actually help to reduce the energy consumptions effectively, and it can help to improve so-called the consumption up to 25%. Yeah? So by looking at the statistics here, in 2040s, we estimate the electric motors will be doubles compared to now, right? So if you look at the cooling system, right, you have actually motors running there as well, okay? So what will impact in terms of business here? So we need to convert from low efficiency models into high efficiency models, right? And then we need to develop a new technologies, right? So induction models, right? There's a lot of losses, and that's why we bring in permanent magnets, and we bring in synchronous reluctance model without magnets in order to achieve IE5 efficiency class, the highest class right now according to IEC standard. All right. So our responsibilities here in ABB, we have high energy efficiency products available, start from IE2 up to IE6. Right? So it's depending on customer needs, application requirements, we apply the right motors in order to optimize the operations with effective way. Yeah? And then decarbonization. Decarbonization means, actually ABB has made a lot of initiative. Instead of manufacturing high efficiency models, we also collaborate together with our suppliers, right? We collaborate with, we make improvement on the productions. How we do it, right? So we have three scopes: scope 1, scope 2, and scope 3. Scope 1 means in the factories, we so-called improve the efficiency of the motors from, let's say, IE1 straight to IE4 or IE5, right? And then we will capture the carbon before it released to the environment. So this is scope 1. So scope 2, we will try to source renewable energy. So instead of buying from the grid, we will buy from so-called the wind generators, right? Wind turbines. We will install the solar panels, right, in order to reduce the carbon dioxide. Yeah? And last but not least, we have circularities. What does it mean, circularities here? ABB is trying to take back the old models. And then we will try to use it or recycle the old models materials, right? And besides that, when we design a new models, we will try to make sure most of the parts that use on the electric models is recyclables. Yeah? So I will explain more on details about these circularities in my EPD's presentation later, right? So by looking at all the information just now, so we have knew that energy efficiency is the main pillars for achieving low carbon societies, right? Up to 37%, according to IEA. Electric motors and drive holds the key for sustainable industry. And last but not least, data is important, right? A lot of motors they just buy, install, and start to run until it fails. But do you know that most of the motors in the market right now, oversized. Oversized means you will consume full energy, but it doesn't give you any values, right? So in ABB, we do have smart sensors. Smart sensors, you just attach on the body of the motors, and we'll start to measure the temperatures, the RPM, the powers, the currents, the vibrations, and etc. It will give you all the data for you to do analysis, whether the motor can be further optimized or the technicians can be monitors the condition of the motor in the control rooms. Right? What Adrian mentioned just now, you can actually use the fingertips to download all the data without accessing to the plant. Yeah? Right. And this is what is happening right now in the world. Right? So there are 2/3 of countries setting up MAPS, MEPS. MEPS stands for Minimum Efficiency Performance Standards. If you look at your home appliances, let's say it's like washing machines, air conditioners, do you see the energy label with how many stars? Right? So in industries, some countries that implemented this, right? They will have the motor registered, tested, measured, how many kilowatt hours will be used by the motors, right? So according to IEC standard, we have IE1, IE2, up to IE5, right? So most of the country, they need at least IE3, that is premium efficiency. Let's talk about like our neighbor countries like Australia, Singapore, China, and so on. The pioneer country is actually Europe. So Europe, they need IE4, super premium, for 75 kilowatt up to 200 kilowatt. So it started already. And in 2026, they need EPD as well. Okay, so I will mention the EPD later on. So by looking at the trends here, everyone is moving towards higher efficiency, all right? So if you look at the carbon footprint of electric motors here, in design stage, basically there is no carbon emission. But when it comes to raw materials extractions or processings, it's about 0.03% carbon emissions. What about the next one? Manufacturing is 0.003%. Okay? Very small percentage. So where is the carbon coming from? It's actually the use stage, when you use the motors. Yeah, because it is consuming electricity 24 hours, 7 days in a week, 365 days. Which means motor is running 8,760 hours in a year. And it is keep on consuming electricity from the grid, right? And therefore, most of the carbon dioxide emission is coming from the usage. And this has shown high efficiency motor is important in order to reduce this or minimize it. And last but not least is disposal, end of life, is only 0.0003%. Yeah? So that is why high efficiency motor play a significant role, right, on this sustainability. So ABB is actually formed between ASEA and Brown Boveri, right? So ASEA and Brown Boveri has started to build motors since 140 years ago, right? And in 1988, they merged together, become ABB, right? And until today, we have all the experience in terms of manufacturing motors, and we have different kind of technology available in motors, right? So I will not show what kind of product we have today because there are too many products, right? But to select the right motors is important in order to optimize your operations, and at the same time, you have the best value in returns. So we have motors available for different segments and also different applications. Okay, so here I would like to emphasize on our new technology called synchronous reluctance motor up to IE5 efficiency class. Right. In the market, IE5, a lot of manufacturers, they are using MANEX, permanent MANEX. But in order to produce this MANEX, you need rare earths substances. And rare earth is not a renewable element. All right? And it will generate radioactive when you want to extract it from the soil. Right? So for ABB, we just change the rotor. If you see at the center here, it comes with a special shape in a U shape, right? And there's no manex. So in between there is hole where the cooling air can pass through. So the whole motor is very cold, right? So when the motor is cold, less heat will transfer to the bearing. There's two bearings, front and back. So there's a study says that if I reduce the temperature bearing temperature by 15 degrees Celsius, the bearing life will be double up. Yeah? And most of the failure of electric motors is caused by the bearing. So in other words, when I improve the lifespan of a bearing inside the motor, the lifespan of the motor will be increased as well at the same time. Yeah? So it is interchangeable, one-to-one. Customer no need to do customization. Just bring out the old motor and plug in the new IE5 motor immediately. Right? And magnet-free motors here, I would like to emphasize here, magnet-free is good because it mitigates the demagnetization risk. When you want to do service, let's say, after a few years, you need to do service, right? Just like your cars. Not everyone can do service on magnets. You need to do demagnetization. If not, your finger will get clips between the stator and rotor. Very dangerous. All right? And it is very difficult to get the right workshop to do the service. All right? The magnet availability that I mentioned just now, it needs rare earths. So it's like minerals. The price of the rare earths will keep on up and down, up and down. Right? So your price of PM models is also very expensive. So in case you need it urgently for a replacement, then you might get in troubles. Okay? And okay. Yeah. So that's why for synchronous reluctance motors, yeah, it's very easy. Everyone can do the service, just replace the bearing, just like in normal induction motors. All right, so let's do a quick calculations here. Let's say I have an IE3 motors, and it's a 110 kilowatts power. So the electricity price is 0.1 euro in 2021. And energy consumption, so here is running every day, 8,760 hours, and average power is 75 kilowatt. So here you can see the saving compared to IE3 is 2,200 euros. And in terms of carbon dioxide reductions is 7.6 kgs per year, right? And the return of investment is 11 months. But when it comes to 2023, this is Europe real case here, where we have this sanction towards Russian. So the electricity price increased to 0.3 euros. So you can see your saving from 2,200 increased to 6,600. And it makes your return on investment only 4 months. So instead of you paying extra money to the electricity bills, you can actually take this money, invest in the high efficiency models, and after the return on investment, all are the savings. Yeah? So this is one of our case study here. Let's talk in Asia, in Australia, where this is somewhere in Tasmania. So they are having pumps in their pool, swimming pool. So the pump used in the swimming pool, they are very old, and it's the so-called the electricity bills is very expensive. So what they do is they replace 19 electric motors to CNRM IE5 with VSD driven, and these are the saving. It's up to 36,000 Aussie dollars, and reduction of 77 tons of carbon emissions, right? Based on the 259 megawatts hour saving. Yeah, so that's give you an 18% reductions in terms of carbon electricity demands. And this is the pulp and papers. I know Indonesia, you have a lot of pulp and papers customers, right? But this is a case in Sweden, your hometown, yeah? So it replaced with 6 IE5 models. And you can see compared to IE2. IE2 efficiency is 88.6%, whereby IE5 is 93.1. So what is the saving? Right? So the saving is 83,000 kilowatt hours per year. right? And the return of investment is 18 months. So the ROI is below 24 months, yeah, within 2 years, 2 years times. Okay, and this is another initiative from ABB. We have established this energy efficiency movement. Why we have this setup here is because a lot of customers, they don't know how to start, how to improve the efficiency in their plant. So we set up a platform where all the users that can join in, they can share their commitments, they can share their ideas, and then they can start to pick the possible solution from others' success cases. Yeah, and from there they start to activate their movement. And right now, we have a lot of company join in into this energy efficiency movement, and ABB has made this platform to a non-profitable body, right? So everyone can join in. It's a independence platform, right? So it's not controlled by ABB. So the next thing is about ABB security platform here. We have 4 pillars here. So you can see we have a security design and sourcings and resources efficient operations, optimized use phase, and last but not least, the responsible end of life. And each pillar has 2 KPI. So you can see design, sourcing, manufacturing, logistic, packaging, and etc. So these are the things that we will do, right? So when we design a model, we will try to use green coppers in our IE5 synchronous reluctance models, right? And we will establish the EPDs, environmental product declarations, and resources efficient operations here. 159 plants will send 0 waste to landfill. That is our ambitious target. 86% of the all waste will send to recycling. Yeah? And optimize the use phase. We will promote our IE5 MANEC-free solution without using rare earths to the market. And then we will promote also our digitalization services, let's say the smart sensors. And last but not least, take back and recycling. We are having pilots in some countries already by taking back the old models and we recycle it. Yeah, so the feedback is quite positive and we'll roll out to other countries as well. Yeah. And this is the EPD that I mentioned just now. EPD.
We have to stop now.
Okay. This is the last one.
Okay.
Yeah, this is the last one. Okay, so the EPD stands for Environmental Product Declaration. It will become a mandatory document in 2026 in Europe. So when you buy a motor, you need to attach along this EPD to show how much is the carbon dioxide emission for the whole life cycles. Yeah. So this is the example of the EPDs, right? So you can see there are different units available, but we will focus on the carbon dioxide. So here you can see the total for this motor, 75 kilowatt motors, is 6.14 kilo. So you can actually multiply with the motor power, and that is the total carbon dioxide emissions. So customer can compare which motor is having the lowest carbon dioxide emissions. Yeah. So, and this is a third-party certified documents, right, according to the ISO standards. Yeah. So very soon you will hear about these EPD requirements, and you need to ask for this EPD from the suppliers and bundle it together with your purchasing. Yeah. So synchronous IE5 from ABB is the first model who get this full range of EPD available. And now we have also available in IE4 models as well. Okay, so if you have any questions, you can start to ask our ABB colleagues in our booth here. Yeah, they are available to answer all your questions. Okay, that's it from my side. Yeah.
Thank you.
Thank you.
Thank you very much. Big applause to Jiam. Yeah, energy efficiency is very important. It definitely is. And motors and drives are everywhere. So great. Yeah, thank you. Okay, so move on to the next speaker from Yokogawa, Mr. Osmond Manuro. So I will just, floor is yours to talk about integration of renewable energy and other things. Yeah.
Thank you very much, Peter.
Yeah.
Very good afternoon, everyone. I hope everyone is not sleepy yet. I'll try to be brief. So, is the slides on already? All right. So I'll talk about the future of energy in Indonesia. I come from Yokogawa, Indonesia. So I'm Indonesian. I head the renewable energy power and water division of Yokogawa, Indonesia. So world's challenge. There are so many things in the world that is uh, facing challenge of politics, society, but we are trying to focus on energy. So the customer trends now has shifted to renewable energy. And then there is a shift of production to environmental friendly products. But then in the process automation industry like Yokogawa, we have maturing product markets, hardware communication, and then growing software and sensor markets. And then we also have to compete with IT companies. So in Yokogawa, we try to utilize our ability to measure and connect. We fulfill our responsibilities for the future of our planet. So measuring represents Yokogawa's origin as a company. We measure things, and our ability to measure is a core competence that Yokogawa must never lose. This is our vision. Through autonomy and symbiosis, Yokogawa will create sustainable value and lead the way in solving global issues. So we also have our vision in 2050 where we can achieve net zero emission as a company. Then we ensure well-being, then make a transition towards circular economy. So Yokogawa, we have a lot of power and renewable reference. We install more than 1900 system for power plants, including renewables. We have our systems in solar, hydro, biomass, gas-fired, and of course geothermal, which is abundant in Indonesia. We have our reference in Southeast Asia, so there is some in the thermal sector, but we also focus on the geothermal sector. So here we see that Indonesia is one of the countries that have abundance of geothermal resource there. Then the next is our contribution towards renewable energy. So I want to share you uh, our products. What we do is we have our system in the generation side of power, and then the transmission side of the power, and then towards the distribution side of the power. We have heard earlier today from Pak Suroso that PLN is moving towards smart grid. In Yokogawa, we have our microgrid solution that is suitable for the kind of smart grid what our country needed. So we have our microgrid solution as well as our energy management system, and then energy tracking system. Then, so this is to summarize the chart you saw just now. We have our solutions in the generation side, in the transmission side, and the distribution side. Okay. Once again, we want to show you our local presence in Indonesia, that we have done so much in the power business. We have our system installed from Sumatra to Sulawesi, and of course in Java. Then I want to show our solution related to today's earlier topic about district cooling. So we have our solution named Asset Health Insights. So later, when you all purchase a district cooling system, we have our solution that we have a dashboard to monitor your assets. It's not only district cooling, of course, but it can be used for many other assets that you have. But we want to show you that we also can monitor your assets in district cooling system through a cloud-based solution. We call it Yokogawa Cloud with real-time information and first principle and AI analysis. So yeah, this is actually an actual model of a district cooling system. So you have an individual asset overview. You have your motors there. You have your tanks. You have your chillers. So you have a nice dashboard that you can use when you already have your district cooling system. Then this is actually my last statement for today. Through autonomy and symbiosis, Yokogawa will create sustainable value and lead the way in solving global issues. And there's a video here you can see while I give the floor to you, Peter. Thank you.
Thank you very much,
Can
Osman.
technologies developed in space be used
Yeah,
here on Earth?
definitely.
Can we make plant-based
There's a big
substitutes for
need
plastics?
to measure with sensors, to manage data, to create, to basically to integrate more renewable energy, right? So it's great to see Yokogawa's offerings, and interesting to see that you also have district cooling solutions connecting with the previous speakers. Great, as well as Siam ABB, of course. Yeah. Okay. Thank you, Osman. So I will move to the next speaker from BSIS Indonesia, Mr. Binu George. Also talk about some renewable energy projects and ongoing solutions. Thank you very much. You have about 7 minutes. Yeah. Thank you.
Yeah, good evening, everybody, whoever is left. My name is Binu George, and I represent BECIS. First of all, thank you, Rana. I mean, it was very nice to hear you. And in fact, I am basically a developer. We are not any technology provider. So in fact, I should have been in the previous where my friends at Keppel and Kijits were there, where we could have spoken about energy as a service. So basically, BECIS, as you see, we are a service provider where we help industrial customers decarbonize. So anywhere in the commercial customers or industrial customers, we help them decarbonize by preparing them for a short-term plan as well as a long-term plan by including anything in scope 1 reduction, scope 2 reduction, or scope 3 reduction. Now, of course, we all know about what is scope 1, scope 2, and scope 3, but still, for the benefit of everybody, whatever direct emissions are happening, okay, so that is falling under scope 1, which is some kind of a gas boiler or a self-combustion system that is there, you can use for scope 1, scope 2, and scope 3. Now, all these three areas where you can bring in renewable projects and you can help decarbonize. So that's where we do. And when I talk about renewable projects, it can be a bioenergy project, it can be a biogas project, it can be cooling project or a district cooling project, it can be energy efficiency, it can be waste heat recovery, or any project that you can implement, help the customer reduce its emissions. And for that, we also finance, we also do the construction, we do the operation maintenance, and we also take the asset management. So anything in scope 1, scope 2, scope 3, all the three sectors we are helping our customers. A typical factory setup, okay? one of the largest areas, like for example, as my friend in ABB said about energy efficiency. If you do energy efficiency, 25-30% of the energy can be saved. Our friends in district cooling said that cooling is one of the biggest load. If you do cooling projects, you reduce your efficiency over there, you can do another 20-30%. In a typical factory, if you see the thermal load for generating steam or hot water or hot air is one of the largest loads over there. If you can transition from fossil fuel to renewable, you can reduce a large amount of carbon emissions over there. So what we are doing is that a holistic view of an factory, a holistic, so on-site generation, whether you put a bioenergy project, a bio-CNG project, a waste heat recovery project, a cooling project, or an on-site solar project. So everything you can combine to make a roadmap for them to do the emission reduction. Now, some numbers, as all my colleagues and friends and panelists said, that we all know the areas where the energy reduction can happen. Okay, so it's not a new technology. District cooling has been happening for the last 25-30 years. Energy efficiency projects have been happening for the last another, 30-40 years. Bioenergy projects have been implemented in Europe for 50-60 years. It's in Indonesia, we are trying to bring everything together now. Okay, we are at an age where the markets are moving, markets are getting educated, the mind shift is happening, and the technologies are available. Like companies, brilliant technologies are available. Developers are available who are ready to invest and help decarbonize. So that's the whole purpose. Financial savings are also possible. If you see greenhouse gas savings, just see bioenergy numbers. Bioenergy, if you put a bioenergy project using agricultural waste, 30-40% or 60% of GHG savings are possible. And then, a very quick difference, whether like district cooling, what we discussed, do you want to invest your own money in building these projects? Or would you want developers like us who would invest their money and, will give you the same returns of greenhouse gas savings, energy efficiency, as well as the commercial savings? If all these three things are done by a developer, as an industry who is like a major in food and beverages or who is a major in FMCG products, would you want to invest in non-core assets or you put your money in the core assets? So that's where OPEX versus CAPEX discussion is happening, where we get paid based on our efficiency. So we would rather encourage people to go for long-term lease contracts where you invest your money in your core assets and allow developers like us to bring in more technologically advanced products and bring in the energy efficiency. And of course, we will guarantee the returns. These are some of very quick, I still have 60 seconds. Okay, so these are some of the very quick project references that are having in Indonesia. So there is on the top that you can see, there are breweries and FMCG major, where we have replaced natural gas with agricultural waste. So we bring the scum paddy, we bring it to the site, we combust it, and we generate thermal steam over there. We have rooftop solar projects where we work with customers, bring in the best inverters that are possible and best panels that are there to bring in energy efficiency. We have waste heat recovery projects. We have chiller optimization projects. Basic purpose of all these renewable projects is to bring in, reduce the greenhouse gas saving emissions, also bring in financial monetary benefits to our customers by zero capex investment. And as I said, products are available, technology is available, developers are available. It is just that yes, time is up. I will. So, as BECIS, we are present in 9 countries And we have a portfolio of all the services that are in solar, bioenergy, biogas, waste heat recovery, or anything in cooling services. So assets spread across all the 9 countries, close to 300 million US dollar of investments are there. And yeah, all the big names that you see in the industrial sector, we have been working with them. Thank you.
Thank you very much. Great, great presentation. It's interesting, you know, of course, energy as a service, also mentioned by Keppel and KJ, you know, it's not only can be applied in cooling projects, can be in renewable energy projects as well. So, yeah, very interesting to see. Okay, I'll move on to the next speaker, Mr. Kin Yoon Lam, who is the Regional Application Engineering Leader at Cargill. I think we're moving into a more power technology. So the floor is yours.
Thank you.
Yeah.
I think I'm not hooked up yet. So.
Yeah, it's coming probably here.
Okay, thanks.
Any minute.
Yeah, but first of all, great pleasure to have the opportunity to speak to you all about how the use of natural ester insulation fluid in transformers can actually help to enhance the sustainability of the power grid. So, I mean, as a start, I guess, you know, we'll talk about what exactly it means, you know, to improve, you know, the sustainability of the power grid. So as we can see here, the dual challenges of needing to, you know, increase to meet the increased energy demand, as well as the need to, you know, to cope with the rapidly increase of renewable energy sources are essentially the key drivers. So instead, you know, our power grid are, you know, needing to face not just, you know, increased loading, but also, you know, more changeable and fluctuating loading, which I guess, you know, we have covered it earlier. So instead of just, you know, merely increasing the capacity of the transmission and distribution networks, the power system operators are actually, you know, obliged to also think of smarter way to increase the lifespan of the equipment and also improve the reliability of the equipment. So for these, you know, what at the same time, you know, trying to drive down the total cost of ownership of the power grid, as well as trying to achieve energy as well as material efficiencies, which I guess, you know, we have covered it a long time. So hopefully that summarizes, you know, what exactly it means, you know, to achieve sustainable power grid. And on the next slide, we cover the basics of, you know, how is possible by using the, you know, the natural ester fluid in transformers can potentially, you know, help to enhance power grid sustainability. So as you can see from the picture here, you know, when the insulating paper we use in transformers is immersed, you know, in natural ester fluid instead of mineral oil, it can actually extend the lifespan of the paper by 5 to 8 times. And as a result, you might not be able to see, but it's in the table below, the maximum temperature limit of the transformers can actually be increased from 15 degrees to 20 degrees higher because of the longer insulating paper life. And on the graph on the right, you can see that, you know, with natural ester fluid, it actually have the capability to continue to absorb moisture from the paper insulation, which is the main reason why the lifespan of the paper insulation can be extended as a result. So on the next slide, we look at how these, you know, the longer paper insulation life, as well as the higher temperature limit of the, you know, of the paper insulation can be utilized, you know, in the design of the transformer. So if you look at the graph on the right, which is essentially telling you, you know, the life of the insulating paper against the hottest spot temperature in the transformer, you can see that, you know, at 0.1, we can essentially use the, you know, the natural ester transformer and operating it at a conventional temperature limit of 110 degrees. But you will end up having a installation life, increased by 5 to 8 times. Okay, and at the same time, at the second point, indicated at point 2, you can actually increase the maximum transformer temperature by 20 degrees, and you can still maintain the same insulation life. So that potentially can actually increase, the loading capacity of the transformer by up to 50%. So what is the advantage of having this? How does it mean in terms of driving power grid sustainability? We look at 2 scenarios. In the first scenario, we indicate here, we have the C-grid transformer survey, which indicate the different mode of transformer failure. And as you can see from the table here, by using natural ester, because of its possibility, of extending transformer insulation life, it can actually help to, reduce the failure of transformer by up to, around 36%. And what it means is, when you look at the next slide, what it means is the overall replacement rate and the average transformer life can be extended by around 20% with mineral oil to around about 20 years for mineral oil to around 32 years for natural ester transformers. And of course, when we look at the total cost of ownership, even if we assume that the natural ester transformer, the initial purchasing cost is 15% higher than an equivalent mineral oil transformers, because of the transformer life extension from 20 years to 32 years, we can actually achieve, anywhere between, 22 to about 30% of total cost of ownership saving because of the longer assessed life. And of course, environmentally, with the longer assessed life, it means that the carbon emission as well as the consumption of non-renewable materials such as steel, aluminum, and copper that is required to make the transformers will also be significantly reduced. So you can start to see how the use of natural ester transformer can drive both economic and environmental sustainability. And on the next slide, we start to talk about the second scenario. Because of the taking advantage of the higher loading capacity of the natural ester transformers, in this case, is a case study done by a transformer OEM. You can see that by replacing a more compact 800 kVA natural ester transformer, taking advantage of its higher loading capacity to replace a conventional 1000 kVA mineral oil transformers, it can actually achieve more than 50 megawatt hour of energy saving over its 30 years of transformer lifespan for just one transformer in a power grid. Okay, so that you can imagine, as a result, it can actually achieve around about 30 tons reduction in terms of carbon emission, again, from just one transformer. So hopefully that start to bring in, the economic and environmental sustainability. And we look at, more closely the total cost of ownership. In the same case study, you can see on the last 2 line here, which is unfortunately we might be partially blocked, but you can see that with or without the consideration of the environmental costs associated to the lower carbon emission, the sheer reduction in the equipment cost as well as the utility costs due to the lower transformer loss, the more compact 800 kVA natural ester transformer can still drive significantly lower total cost of ownership compared to the conventional design. So moving on, we have one case study that is actually the application of the design that I have been talking about in a solar PV system projects. So in this project in Spain, you can see that all the 21 natural ester transformers deployed here are of conventional rating of 5,000 kVA. But because of the use of natural ester fluid in the transformer, it can actually withstand a maximum peak loading of 7,000 kilowatt from megawatt from the solar system. So as a result, you can see that not only the equipment cost and the equipment footprint can be reduced, which is very important for renewable energy, of course, especially the reduced equipment footprint. But more importantly, about 14 tons of steel, aluminum, and paper can be conserved for this project. And over 40 tons of carbon dioxide can be eliminated during the manufacturing of the transformers. So I hope this short presentation, by looking at two approaches, one of them using the conventional approach by extending the transformer life, the other one, taking advantage of the higher loading capacity of the natural ester transformers to replace a much larger conventional mineral oil transformers, hopefully explain how it can drive both the economic as well as the environmental sustainability of the power grid. So at this point, thank you, and I pass the time back to Peter.
Thank you very much. Applause for Kinyu. It's very interesting to see here what you can do with replacing mineral oil in transformers. It's very interesting. So we're going to move on to the last speaker, Mr. Hogan Liao from DuPont.
Hello everyone, good afternoon. It is my pleasure to be here, join the electric and power exhibition. I'm from DuPont, and today I want to use this unique chance to introduce our DuPont and our product Nomax for you, which can help you to enhance your equipment safety, reliable, and economics. Yeah.
Can we get the last presentation? And thank you for staying with us.
Thank you. Yeah.
It's good to see you all.
Yeah. Actually, from my personal side, when I sitting here for the whole afternoon, listening a lot of experts introduction, I learned a lot, and also for my presentation is also well covered the global climate change, global warming, and energy efficiency. So we have some common points. Okay, this is my first slide. First, I want to introduce our company, DuPont. DuPont is a scientific and innovative company which provide technology-based material and a solution to our customer. We innovate a lot of wonderful product. Okay, you can see like Nomax, Kevlar, Nylon, Leica, Tavik, Mylar, Captain, and so on. Here are two examples. The first is Apollo 11 moon landing in 1969. For the space suit, there are 21 layers of material. Among these, 20 layers are innovated by Dubon. And another case is President Nansen's Mars rover. This is landed in 2021. Also, Nomex material was used to withstand the house environment and maintain the normal operation of this rover. Nomex is one of the most famous materials that Dubon produced. And Nomex is a Dubon registered trademark for its families of fiber, filament yarn, paper, and pressboard. Nomex have high strength polymers with unparalleled high temperature and flame resistance. It can be self-auto-exhaustible, and also it UL recognized 220 degree in solution material. Besides the thermal performance, Nomex have also excellent mechanical and electrical performance. It's a high tier resistance and edge cut and high tensile strength, excellent arc resistance and resilient for bending. And also, Nomex is compatible with most of in solution varnish and transformer oils and resin gases. So it's widely used in the electric in solution industry. Nomex is widely used in our daily life. From this picture, you can see Nomex can be used in electric infrastructure, which is like our power equipment, like transformer, as Kim mentioned, and also generator, as ABB mentioned, and also can be used in hot gas fitment, and also automotive, like EV cars, and also aerospace. The airplane, for your travel, Nomex were also there, and also for some military defense and enforce. Also, there are many applications. So let's back to our topic today, because today we are electric and power exhibition. So we focus on the power equipment. Today we covered the Nomex application in transformers. As Kim mentioned right now, Nomex can be used in almost all type of transformer, including vacuum pressure impregnated transformer. We call it VPI transformer, and also liquid immersed transformer, which is just Kim mentioned. The liquid can be FR3 or can be mineral oil and also other liquids. And another is the cast resin transformer. We call it CRT. Nomex had been widely used in all these kind of transformer. Today, when talking about the growing demand on electricity and also climate change, global warming, and so on, the industry try to find new solutions, including a lot of have done by ABB and Kakio. Also, our Dubon also have our solution. Kakio provide the liquids. Our Dubon Nomex provides the solid in solution to the liquid field transformer. Like a conventional transformer use cellular-based paper and pressboard. We can provide another option, which is armid paper and pressboard For example, Dubon Nomex. Besides the industry and the customer try to find a new solution, and also we see for the transformer industry, the global standard community, including the IEEE and IEC also working on this because there's a strong demand. IEEE revised their high temperature transformer standards in 2022, and the IEC, the latest version is 2013. But now our Dubai expert working together with transformer experts from globally on the IEC standard revisements, and the high temperature requirement will be added on the part 1 of the general requirement. This is the thermal life of our Nomex compared with our conventional insolution material. You can see the right one is the cellulose paper. We call it calf paper. This is thermal index is 19H. It's quite similar to what we know in IEC standard. And the middle one is the TUK paper. This is from our test. It's 112. It's close to 110, as the IEC mentioned. We reference these two candidate system. We immersed our Nomex in mineral oil and tested the Nomex thermal index and found that Nomex therm can be 230 degree thermal index, which is much higher than the highest transformer industry class for liquid field application. Currently, for liquid transformer, the highest class is class H, which is 118. So if you use our Nomex, your transformer will have pretty much margin, so it will be reliable and safety. This is, as Kim mentioned, that their FR3 is a natural acid, is very hot, not only in Indonesia, but also globally. We Duban also do this kind of compatibility test with different liquid, also including FR3. We have tested for sunflower, natural acid, and the Symbon natural acid from FR3, and also synthetic acid. We found that this is our test results. You can find the test data and the conclusion in the bottom. The test results show that the performance of Nomex paper was not affected by the liquids. All this liquid have no negative impact on our Nomex paper. How about the liquids? We also have this test data from different liquid supplier, including synthetic ester and natural ester. Also, the performance of this liquid was not affected by our Nomex paper. So, our Nomex paper are fully compatible with different insolution liquids. Since the transformer industry normally have two types of winding. The first one is disc winding. Our Nomex can provide the whole solution to our customer. We can use our Nomex 410 as conductor in solution, and use our Nomex 993 or 35H paper as edge collar. For stick and spacers, Nomex 994 can be used. Cylinder are normally used with Nomex 993, and anchoring caps nuts are used with Nomex wetboard. We have different type of Nomax because there are different requirements and different properties which is required for a transformer. And another is for layer winding. This is normally used in distribution transformer. Here you can see similar. We have Nomax 410 for conductor. And for layering solution, we also have DDP paper, which is also produced by Nomax. And also the end filler with Nomax Pressboard 993, stick and end supports with Nomax 994, and the cylinders and barrels with Nomax 993. And the creep papers, we have Nomax 910 and 411. We have the whole solution for you. If you want to design a high temperature transformer, we can provide you with our partner, FactSlip, with the whole solution for you. This is
Mr. Hogan, I get the indication here we have to wrap it up soon. So,
okay, very quick, yeah. This is, you can find more details, information on different type of our Nomax for different components. This is transformer components made by Nomax, not cellulose. Okay, besides for liquid application, we also, Nomax is widely in dry type transformer. You can see CRT transformer, VPI transformer, and also for reactors, for inverter system and converter system. Nomax can not only provide the discrete paper and pressboard, we also can provide the laminate product such as NMN, NNKN, and NHN, which our partner can also provide to you. If you request, please contact us. Besides this, if you transformer want to export to US market, you may need a UL system. Our Dubon have plenty UL system which is worked in the industry for almost 40 years, and we have nearly 500 UL system. There should be someone fit for you. If you have new requirements, which is different with our existing system, please contact us. We can develop it together, and we can modify it for you. And this is our two UL system for transformer. One is for class R. The HV wattage is 50 kilowatts, and another is 35 kilowatts, also class R transformers. Due to the limit of time, so I speed a little bit up in the last part. But if you have any questions, please contact us, contact FactSlip or Dubon. Thank you.
Thank you very much, Hogan. Interesting to also learn more about your solutions as a very old and established company. Yeah, so I've been told here by my event partners here that we have to wrap up the session. I think we have had 5 great presentations, and please, if you have any questions, just grab us after instead. So thank you very much. A big hands to the speaker, and back to you, the moderator. Yeah.
Okay, we would like to thank the speakers who have given great knowledge to all of us, and please be available to stay on stage. And next, we invite you to come up to the stage for the memento presentation and photo session. We also invite a representative from Country Manager PT Pamerindo Indonesia, Ibu Lia Indria Sari, to join us on stage to present mementos to the speakers. and everyone who has participated in this event. Before we conclude this event, we invite you to join us for tomorrow's exciting agenda. We will have the collaboration talk PGCI, X, and BRI on Road to Battery Show Innovation in Energy Storage and Battery Technologies Recycling for Sustainability from 9:30 to 11:30 waktu Indonesia Barat, followed by the Indonesia Sustainable Update session on empowering Indonesia's renewable energy future, developing a skilled and sustainable workforce from 13:30 to 15:35 waktu Indonesia Barat, both taking place at the Trademark Building GPN. Thank you, and I'm Firly Istighfarin signing off. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon and see you soon.